So right now we're going to talk a little bit about the end behavior of a function. In other words, we want to know what happens to the y value or the height of the function as x becomes very large. So before we look at some examples, let's just make sure everybody knows what the quadrants are on the Cartesian plane or on the x and y axes. So first of all, in this top right hand corner, we call that quadrant 1, Q1. This is quadrant 2, quadrant 3, and quadrant 4. So it just goes counterclockwise around the grid. All right, so end behavior, here we go. So here we have a graph of a function, a really pretty graph here. What we're interested in knowing is what happens to the graph as x becomes very large. So as x gets very large on each end of the x-axis, we want to know what's happening or to the height of the graph. Where is it going towards? So this end, far end of the x-axis, is heading towards negative infinity, and on this end, x is heading towards infinity. So this is the x-axis. We want to know as x is going towards those two large end values, what's happening to the graph. So if we look here, as x approaches positive infinity, the graph is heading up as well, very, very high on the y-axis or on the y values towards infinity as well. So it's exiting the grid through what we call the first quadrant. When it leaves through quadrant 1, that means it's approaching infinity. On this side, as x approaches negative infinity or becomes very large this way, the graph we can see is heading down, 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 down. It's heading towards negative infinity as well because it's leaving through quadrant 3. So it's leaving this way, quadrant 3, leaving this way, quadrant 1. Or if we're reading the graph just from left to right, it looks like the graph comes in through quadrant 3, does some stuff in the middle, and then goes out through quadrant 1. So our end behavior is going to be described down here. What we're going to write is, I'm just going to separate that out there, as x approaches infinity, comma, y approaches, so as x approached infinity, y also approached infinity. As x approaches negative infinity, so going out in this direction, y approached negative infinity. So as x approaches infinity, y approaches infinity. As x approached negative infinity, so did y. Let's look at the next example, see if it's the same. So here we have a parabola. This should be a very familiar shape to you. And let's look first of all this time at what happens for large negative values of x. So as x is going out this way towards negative infinity, what's happening to our function? Well, our function is going up and up and up and up, and it's going to keep going up towards positive infinity. So as x approaches negative infinity, that's this bottom one, as x approaches negative infinity, y is approaching infinity because it was going up and up and up through quadrant 2. And on the other side, as x approached infinity, y, on the other hand, is also going up and up and up and up, approaching infinity. So it's quadrant 1. So as x approached infinity, y approached infinity. So in this case, both of the ends of the function are approaching infinity. We can think of it as we read from left to right. It comes in quadrant 2, goes out quadrant 1. That's the informal way of saying that y is approaching infinity when x approaches infinity and x approaches negative infinity. One more example. So here we have a very interesting function which we will examine later on in the course. It's called a rational function. And there's a lot of funky stuff going on here in the middle. We've got some discontinuities, but what we're concerned about right now is what's happening at the ends of the graph here, out here on the very ends. Okay, that's our main concern right now. So for the end behavior, again, we want to look at what happens as x approaches negative infinity, and what happens as x approaches positive infinity. So for this graph, as the x values get bigger out towards the negative infinity side, the graph itself isn't approaching positive or negative infinity. It looks like it's kind of leveling out here, getting really close to whatever this number is. Well, that's 5, so 1, 2, 3. So y is actually approaching 3. The height of the graph is approaching 3 as x approaches negative infinity. And on the other side, as x approaches positive infinity, it's below 3 here, but it's creeping back up there, so it's also approaching 3 on this side. So as x approaches positive infinity, y is approaching 3. And that's how we can define the end behavior of a function.